Welcome to my channel. In the previous video, we discussed about MNST dataset. MNST dataset. It contains 70,000 images, 70,000 handwritten images, okay, images, out of which 60,000 images are used for the training and 10,000 images are used for the testing purpose. Okay, so all these images contains like 0 to 9 handwritten digits. Okay, now and also we discussed about the training a binary classifier. That means classifier. Here in this video we discussed about binary classifier, like whether the given digit is 5 or not 5, and also in the previous video we discussed about the performance of the models, performance measures of the models, okay. Now in this video we are going to discuss about the measuring accuracy using the cross validation. So here a good way to evaluate the model is you have to use the cross validation. Based on the cross validation we are going to find out the accuracy of the model. Okay, so we are going to use the function called as a cross underscore val underscore score function to evaluate our model. Our model is here stochastic gradient descent classifier model. Now using the KFold cross validation with 3 folds. What meaning of KFold cross validation? Here in our example there are 60,000 data instances are there. 60,000 instances are there. These 60,000 instances are divided into 3 folds. Okay, randomly we are dividing them into 3 folds. There is here this is a fold 1 and second fold, third fold. Okay, it contains 20,000 randomly images, and here the fold 2 contains 20,000 random assigned images, handwritten images, and 3 fold contains randomly assigned 20,000 images. Okay, now like that the 60,000 is divided into 60,000 handwritten digits, handwritten digits divided into 3 folds. Okay, each contains 20,000 images. Now this is called as a KFold cross validation. So now here the KFold cross validation means splitting the training set into KFolds. Here 3 folds. This is a fold 1, first fold, second fold, and third fold. Okay, now like that we are going to divide into 3 folds. Then we are making the predictions using the evaluating them on each fold using a model training on the remaining folds. That means, for example, if we are going to use the first 2 models for the training purpose, based on third fold we are going to predict the values. That is the one way. And in the second combination, the first fold and third fold are using for the training purpose, and based on the second fold we are going to predict the corresponding values. So that is one way. And based on the second fold and third fold as a training purpose, and we are going to find out the predictions on the first fold data. Like that we are going to find out the performance of the each and every fold performance. Okay, simply this process is called as a cross validation process. Okay, now here from the scikit-learn model underscore selection we are importing the cross underscore val underscore score function. So here from the cross underscore val underscore score function we are providing the different parameters like stochastic gradient classifier. Our model is a stochastic gradient classifier, and training data, extend data, y underscore train underscore 5, and cross validation equal to 3, and scoring equal to, or the accuracy performance of model is based on the accuracy. Okay, now after executing this statement we will get the three performance measures. Okay, accuracy values like 0.96355, 0.93795, 0.95615. So in all the cases, all the three values are above 93% accuracy. We are getting in the all the three cases. Okay, and all the three cross validations. Now look at the we are going to use the one more model that is called a dumb model, dumb classifier. Just it's like a classifies every single image in the not 5 class. For the not 5 class, there are two classes. One is a 5 and not 5, not 5. Okay. So here from the we are going to develop the model called as a or dumb model. Okay. From the scikit-learn.base, we are importing the base estimator class never 5 classifier. So the base estimator is the parameter. So here we are going to define the two functions. One is a fit function and one is for the predict function. For the definition of the fit function, we are providing the self and the corresponding x value, corresponding y equal to none value, and we are going to return the self value. Define predict self comma x. Okay, return the np dot zeros length of x comma 1 and the data type equal to boolean values. Now, so you can find out the accuracy of this model. Okay, so here never 5 underscore 5 classifier equal to never 5 classifier. So we are finding out the cross validation score value for the never 5 classifier, never underscore 5 underscore classifier. So for that we are providing the x train value, y underscore train underscore 5 value, the cross validation equal to 3 and the scoring equal to based on the accuracy. So we are getting the values of 0.9, 0.91125, 0.90855, 0.90915. Okay. Now, in all the three cases, we are getting the accuracy above the 90%. Okay, now. So, this is simply because of only the 10% of the images are five classes. Okay. Out of all that 60,000 images, only 10% are belonging to the class level 5 classes. Okay. So, if you always guessing that the image is not a 5. Okay. That is the way. So, you will be right about the 90% of the time. So this demonstrates why the accuracy is generally not the perfect performance measure for the classifier because especially when you are dealing with this is because of the skewed data. You are dealing with your skewed data. That means 5 and not 5 data. So here 5 data contains only 10% of data and not 5 contains 90% of data. There is no equal distribution of the 5 and not 5 classes. That's why this data is called as a skewed data set. Okay. So that's why we are using that. We are saying that the accuracy is not the perfect performance measure for the classifier. So that is why when some classes are much more frequent than the others. Okay. So in order to implementing this cross validation, occasionally we will need to more control over the cross validation process than what the scikit-learn provides of the self. Okay. In these cases, we can implement the cross validation by yourself. Okay. So this is the why we are going to use the performance of the accuracy by using the cross validation. Okay. So here the cross val the performance of the model is not only depends on the accuracy. We can use the other models like confused matrix. In the next video, we are going to discuss about the confused matrix. Thank you for watching our video. Thank you.